Yes. Yeah. So the purpose of IP addresses that why we discuss, the question is, why should I or why should one take this particular network layer introduction part means, as you know that you need a router to get outside of your local network, right? So but the routers alone cannot do the job, because you need a proper IP address for both the source and the destination address. So there is a lot to know about the IP addresses, including that each one has a network portion and a host portion in that IP address. But of course, there is more to IP address than that. That is, this particular chapter will explain the internet protocol, then the structure of an IP address, IP version 4 addresses, as well as how and when these IP addresses are used that we discuss here. But just you wait, there is more that you will learn how to convert a binary IP version 4 address to a decimal and vice versa. So you just believe me, it's more fun than it sounds, and knowing how to do this will put you ahead of the pack. So just see what we learn in this particular chapter means the purpose of an IP version 4 addresses, which explains the purpose of an IPv4 address, and then the binary conversion of your IPv4 address, that is calculate the numbers between decimal and binary systems, and then we talk about the IP version 4 address structure that explains how this IP version 4 addresses and the subnets are used together. Then we talk about the classful IP version 4 addressing that describes the different IP version 4 address classes. Then we talk about the public and private IP version 4 addresses that describes the public and private IP version 4 address ranges. Then we talk about the unicast, broadcast, and multicast addressing. Okay, so in the computer networks, the most important part in computer networks, the most important part is just to know about the devices and how those devices are identified in the network. To identify those devices, we use IP addresses. In that IP addresses, what are the different versions are they? So that is IP version 4 and IP version 6 is there. Then in this IP version 4, for what purpose we use, and what is the structure of your IP version 4, then what is the representation of your IP version 4 in terms of your binary representation, in terms of your decimal representation. So how the decimal IP version 4 is converted into binary, and how the binary IP version 4 is converted into decimal that we discussed. Then the structure of your IP address 4 that we discuss. Okay, then we talk about your public IP addresses, private IP addresses, and so and so. Clear? Yeah. So here you can see the IP version 4 addresses. So a host needs an IP version 4 address to participate on the internet and almost all local area networks today. Okay, that means, I just repeat, the host needs an IP version 4 address to participate on the internet and the local area networks. So the IP version 4 address is a logical network. Remember, IP version 4 is a logical, IP version 4 address is a logical network address that identifies a particular host, not physical. Physical comes in the data link layer. This is only the logical, means the address which is assigned to a particular device at a particular instance of time may not be same for the next booting. That may be changed. That's why we called it as logical part, right? So this IP version 4 must be properly configured and unique within the local area network for local communication purpose. So it must also be properly configured and unique in the world for remote communications. So this is how a host is able to communicate with other devices on the internet. So an IP version 4 address is assigned to the network interface connection we used to call NIC. Remember, NIC, network interface connection for a host. So this connection is usually a network interface card. Network interface card. Remember, somewhere you might have heard about this one. What is NIC? What is NIC? You might have heard about this one. Okay. So you find the NIC cards. Okay. The network interface card means every device will have a port. No, that port is sometimes we used to call it as the network interface cards. Clear? Okay. Or NIC. So these NICs are installed in every device. Every device. It may be your Ethernet NIC, it may be your Wi-Fi NIC. Okay. The examples of this end user devices with network interfaces that includes the workstations, servers, network printers, and IP phones. Clear? So some servers can have more than one NICs, and each of these has its own IP version 4 addresses. The router interface, or the router we used to call our router interfaces that provide connections to an IP network will also have an IPv4 addresses. So every packet sent across the internet has a source and destination IP addresses. So this information is required by networking devices to ensure the information gets to the destination and any replies are returned to the source. Okay, so this is the case. I'll just give you the demonstration by just playing one thing. I'll just stop this. Let me share a tab. Okay, and just see. No, not this one. Stop. Okay. Okay, this one. I'll just play this and you just. Mm-hmm. You just see here in this. I'll just play this and you just observe what is happening here. You just see the IP addresses 64 dot and a 0.0 that goes through internet and that will reach to your 64.100.0.1 server, that is cisco.com server. Okay, for your purpose, I'll just play it again. Just see, there is one message generated by this user and the destination is 64.100.0.1 and that message is going through the internet and it is reaching to the destination, that is cisco.com, and from there the acknowledgement is coming back to your sender. The acknowledgement coming back to your sender. Is that visible? Have you feel that? Is that visible? Can anyone respond? The play, have you observed? Okay. Shall I play one more time? Ravindra, shall I play one more time? Okay. Okay. Abhishek said, okay. Okay. See. Yeah. Here is the source. Want to send to the destination cisco.com with the 64.100.100.0.1, and that message is going on that envelope that reach to destination. As per transport layer, it will generate acknowledgement. That acknowledgement comes via the internet and reach to your source. Reach to your source. Is that clear now? Yeah. So now I'll just share this. Yeah. So this is what we observed. Okay, in this diagram, right? So here we just played the every packet sent across the internet has a source and destination IP addresses, and this information is required by the networking devices to ensure the information gets to the destination and any replies are returned to the source that we observed in this play, right? So now let us see what is the representation of your what we call the representation of your the IPv4. The representation is binary conversion of your IPv4 address. Okay, so how it is happening that we observe now. So an IP version 4 address is simply a series of 32 binary bits. Simply a series of 32 binary bits, that is ones and zeros. So there are over 4 billion possible IP version 4 addresses using a 32-bit addressing scheme. How many? 4 billion possible IP version 4 addresses are using by your 32-bit IP addressing. So it is very difficult for humans to read a binary version 4, IP version 4 address. So for this reason, the 32-bit bits are grouped into 4 8-bit bytes called octets. 4 8-bit bytes called octets. So an IP version 4 address in this format is hard for humans to read, right, and remember. So to make the IP version 4 address easier to understand, each octet is represented as its decimal value separated by a decimal point or period. So this is referred to as dotted decimal notations. This is referred to as dotted decimal notations. When a host is configured with an IP version 4 address, it is entered as a dotted decimal number, such as here in this diagram you can see 192.168.5, sorry, 1.5. Are you observing here? दिख रहा है? ये IP address IP version 4 बोल रहे हैं. That means what? If you write 2 to the power of 4 is equal to how much? 2 to the power of 4 is equal to how much? What is the value? 32, right? So Internet Protocol version 4 means Internet Protocol size of version 4, that is 2 to the power of 4 is equal to 32 bits. So these 32 bits are in the binary form, zeros and ones. Okay, 0, 1, 0, 1 and so and so. ऐसे कब तक रहेगा ये? 32 बिट, 0 से लेकर 31 बिट तक हो गया. क्या इंसान ये 0s and 1s याद रख पाएगा? नहीं रख पाएगा, right? That's why these 32 bits are divided into 4 bytes, 4 bit bytes. ठीक है, यानी कि कितने हुआ? 4 पार्ट हो जाएगा. ये मान ले एक 4 बिट बाइट हो गया, एक 4 बिट बाइट हो गया, एक 4 बिट बाइट हो गया, एक 4 बिट बाइट. ठीक है, 4 बिट. अब ऐसे नंबर को याद रखना भी मुश्किल है. ऑक्टेट में मतलब 8 बिट्स होते हैं, 8 बिट्स को याद रखना भी मुश्किल है, तो इसलिए क्या किया, दोज ऑक्टेट्स आर कन्वर्टेड इनटू डेसिमल पार्ट and those decimals are separated by dots. So that's why we call IP version 4 addresses are referred as your dotted decimal notations. ठीक है, और वो डॉटेड डेसिमल नोटेशंस किस लिए, हर कोई डिवाइस इन द इंटरनेट उसको रिप्रेजेंट करने के लिए, कैसे रिप्रेजेंट करेगा, मतलब इट शोज लाइक दिस 192.168.1.5 is the way of representation. ठीक है, I think it is somehow clear. क्या क्लियर है? Is it clear? Okay, ठीक है. Right, so then we move. Right. So when a host, as said, is configured with IP version 4 address, it is entered as a dotted decimal number such as 192.168.1.5. ठीक है? So the 32-bit binary equivalent is, for this number is, you can see 11000000 11 4 6 zeros 10 10 10. You can see here. This value is equal to 1 2 3 4 5 6. This one 1 2 3 4 5 6 7 8. This one. This is another byte and this is another byte. ठीक है, अब यहां देखोगे तो ये हो गया 5, ठीक है, ये हो गया 1, ये this value is equal to 168 and this value is equal to 192. ठीक है, ओके. Okay, good. Yeah. So then, I'll share another screen for your better understanding. Yeah. Is that screen is?
In this video, we're going to take a look at the binary number system. We're also going to see how to convert from binary to decimal. First, a brief look at the fundamentals of number systems. In all number systems, the first digit begins with 0. So whatever base we're working in, that tells us how many digits or how many numbers are in that number system. For example, decimal, base 10 number system has 10 digits. Starting at 0 through 9, that's our 10.
Is that voice is audible or any disturbances? Is that voice is audible or any disturbances? Ravindra, वो आवाज सुनाई दे रहा? ओके, कुछ डिस्टर्बेंस दिखाई दे रहा क्या जयशंकर? कुछ डबल डबल ऐसे सुनाई दे रहा क्या? जय,
$10 digits. Binary is base 2. Base 2 has 2 digits. Starting at 0, 0 and 1 are our 2 digits. So the first column in our number system is always the column of ones. Whatever base we're working in, the next column is that times the previous column. Let's take a look. In base 10, the first column is the column of ones, our rightmost column. Base 10 the next column would be 10 times 1, or 10. The next column would be 10 times that, 10 times 10, or 100. The next column, 10 times 100, 1,000, and so on. In base 2, we also start with the column of ones. Base 2, the next column would be 2 times the previous column, or 2. The next column after that would be 2 times 2, 4. The next column, 2 times 4, 8, and so on. So in base 10, we said the first column is the column of ones. Next column is 10 times that, 10, and 10 times that, 100, etc. What digits can go in each of those columns? Well, any digits in our number system, 0 through 9. So whatever I put in the ones column is how many ones I have. Like 1 is 1, 1. 2 would be 2 ones. 3 would be 3 ones. 9 would be 9 ones. And that's actually the last digit in our number system. So 10 would be 1 in the tens column and 0 in the ones column. That gives us our 10. So the 1 in the tens column means the number of tens, as opposed to the 1 in the ones column, which is the number of ones. 99 would be 9 tens and 9 ones. 100 would be 1 100s, 0 tens, and 0 ones. Now this may seem really basic, but understanding base 10, the decimal number system, you can understand any number system. Let's take a look at the binary number system. The binary system, the first column is our column of ones. The next column, because base 2 is 2 times this column, so that would be 2. The next column, base 2, 2 times 2 is 4. The next column would be 8, and we'd keep going, but we're going to leave it at this. Okay, so what can go in each one of these columns? Well, we're using base 2 binary. So we only have a choice of 2 digits, a 0 or a 1. Let's take a look. So a 0 in binary, 0 ones, that's equivalent to a 0 in decimal. A 1 in the ones place is equivalent to 1 in decimal, a 1. Now remember, in binary, we can only use a 0 or 1. So 1, 0, what this means is how many 2's do I have? I have 1, 2, and 0 ones. That equates to 2. 1, 1 in binary is 1, 2, plus 1, 1. 2 plus 1 is 3. 1, 0, 0 in binary is 1, 4s, 0, 2s, 0, 1s. So we have 4. Wherever we have a 1, we just add up that column. If we have a 0, we don't add that column. It's that simple. So as we can see, five would just be 1, 0, 1. 6 would be 1, 1, 0, 1, 4, 1, 2, 0 ones. 7, 8 would be 1 in the 8s and 0 in the 4s, 2s, and 1s. 9, 10. 10 would be 1, 8 plus 1, 2. 8 plus 2 is 10. 11, 12, 13. So 13 is 1, 8 plus 1, 4 is 12 plus 1 is 13. 14, 15. 15 is 1, 8 plus 1, 4 plus 1, 2 plus 1, 1. 8 plus 4 plus 2 plus 1 is 15. So what would 16 be? You're right. 16 would be, we'd have another column over here of 16s. 2 times 8 is 16, so we'd have another column over here, and it would be 1 in the 16s column, followed by 0, 0, 0, 0. So let's look at how to convert from binary to decimal. It's very simple. So given this binary number, what would be the decimal equivalent? You're right. All we have to do is add up wherever we have a 1, add up that column. We have 1, 2, 0, 1s. That gives us 2. What would this be? You're right. 1, 8 plus 1, 2, that's 10. How about this? We have 1 in the 16s, 1 in the 1s. What's that give us? You're right. 16 plus 1, 17. How about this? Notice that each column is 2 times the previous column. So 164 plus 1, 4. See, that's 68. Plus 1 in the 2s, that's 70. I have 0 everywhere else. 70 is the answer. How about this one? Oh, 1 in the 128s. What else do I have? 1 in the 2s. 128 plus 2, that gives us 130. And let's take a look at this last one here. Oh, that looks tough. A lot of adding to do, isn't it? So we'd have to add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. What does that give us? 255. And there's actually an easy way to figure that out when we have all 1s in this column. What would be the next value after 128, the next column? Well, that would be 256. So 256 would be 1 in the 256 column, and then all zeros. So if the next column is 256, and we have all 1s here, we just subtract 1 from 256, and that's 255. That doesn't make sense. Don't worry about it. All you have to do, again, is add up wherever we have a 1 in that column. Add those column headings up, and we get the answer.
So that's, we observed means how to do the conversion from binary to decimal and decimal to binary. So there are different methods there. You can follow our Indian method also. To convert any decimal into binary, what we simply do, take that decimal value and divide that by 2. Whatever the reminders comes, those gives your zeros, ones, zeros, ones, and so and so. So that will one way of converting from your decimal to binary. Yeah, easy ways are there. Yes, there are multiple ways. So this is a way of conversion of your Cisco from binary to decimal and decimal to the binary part. Okay, so I would like to stop this session here, and I request all the students to go through your portal and give the feedback. Okay, and I don't know what was the problem. Students have given different kinds of feedbacks. From EC1, I can say sense here that there are 42 students given feedback, and the percentage of feedback is 33.33. So have not given at least a distinction of my pass marks. So that's okay. So if you guys having any kind of difficulties while attending my classes and understanding my classes, you would have every time I'm asking you that whether you are understanding or not the concepts. So accordingly, you just see and let me check it out. Your feedbacks one by one. Who has given what kind of feedback? Okay, and I'll try to improve myself because maybe I'm following as the European system, maybe which is giving a kind of gap between your understanding and my understanding. So let us see. But anyhow, I request all of you to type your enrollment number in the chat box and be ready, chat box, and then you can quit the session. But I request everyone to complete your feedback by today, so that let me check it out. What should I improve from my side? So, are you giving feedback now? I'll just check it out. Now we have another 5 minutes. You try to give the feedback now.